Let's continue. Yes. In the previous video, we started talking about conditions for equilibrium. And the first condition we stated was that the system that must undergo equilibrium must be reversible. That is, what does a reversible reaction mean? A reaction that proceeds at both forward and backward direction. So, for example, our process here. So, a reversible reaction is usually denoted by this type of arrow. Forward arrow and backward arrow. That is, this reactant forms this product. Then this product can break down again and form back the reactant. So, this above reaction that we can split it into two. Into forward reaction. The forward reaction that is what? Is controlled by the arrow up here. You can see the bottom of the arrow. The reactant is here, which is nitrogen plus hydrogen. And the product, the front of the arrow is what? Ammonia, NH3. Then the backward direction, you can see the arrow down now is controlling the backward reaction in which the bottom now is pointing to the reactant. And the product is on this pointed mouth. So you can see, so that is that. Then I also said that the rate of forward reaction must be equal to the rate of backward reaction. The rate at which forward reaction is taking place must be equal to the rate at which backward reaction is taking place. Then, number three, the reaction, the system must be a closed system. Must be a closed system. Otherwise, the reaction would come to completion. That's to tell you that any reaction that is at equilibrium does not end, it continues. If nitrogen reacts with hydrogen, it forms ammonia. The ammonia breaks down and forms the hydrogen and the nitrogen back. The two of them react together again. They form this one. And that reaction is a what? Continuous. A system at equilibrium does not come to completion. But if you want it to come to completion, open the system. Am I talking? If you open the system, the ammonia will escape. The product will escape. There will be nothing again to break down again to form the nitrogen and the hydrogen again. And the reaction will come to completion and there will be no equilibrium again. Are we together? Yes. So the reaction must take place in a closed system. Then another thing is that catalyst speeds up the rate of attainment of equilibrium, but it does not determine the position. It does not determine the position of equilibrium. Take note of that. We have stated this one under the general properties of catalysts. Later, what we mean by a position of equilibrium, we are going to talk about that. But catalysts make a system to attain equilibrium quickly, faster. But it does not determine the position of what? Equilibrium. Take note of that. Now, then about 5 points. The fifth point here is that temperature of the system must remain constant. Must remain what? Constant. Temperature must remain the same. Hello? If temperature does not remain the same, equilibrium will shift. We are going to what is responsible for that? That is Le Chatelier's principle. We are going to talk about that. If the temperature increases or reduces, equilibrium will shift its position. Equilibrium will do anything. We shift its position. So that's the time that change in temperature can affect equilibrium position, but catalyst cannot affect. What do you mean by position? Equilibrium is staying here. It's now going to be shifted when there is increase or decrease in temperature. But addition of catalyst, presence or absence of catalyst does not shift equilibrium. But the presence of catalyst make a reaction to attain equilibrium faster. Are we there? We are still going to talk about that. Now, another thing is that the pressure of a gaseous system must be kept constant. The pressure of a gaseous system must be kept what? Constant. If the pressure is not kept constant, equilibrium will shift. Equilibrium will do it. We shift. So, and don't forget, pressure only affects what? Gaseous system, like in our process now. And when we are talking about increase in pressure, we are talking about adding more to the ammonia. Adding more to any of these gases. If you add more ammonia, you are increasing the pressure of ammonia. Am I talking to you? Yes. When you add more to this one, you are increasing the what? The pressure. And it will make the equilibrium to shift. We are still going to talk about that under Le Chatelier's principle. Now, the next one is that the concentration of a non-gaseous system must be kept constant. You see, for a gaseous system we have pressure, but for a non-gaseous system we have what? Concentration. Increasing the concentration of the reactant means adding more to the reactant. Am I talking to you? Yes. When you are adding more, you are increasing the concentration. So don't add whatever thing you have in the system, leave it like that. Then it will continue to go forward, backward, forward, backward, forward, backward. But the moment you add to part of the reaction, the equilibrium will do what? Will shift. So, but you want the equilibrium to remain, then all these factors must be in place. Now let's now look at Le Chatelier's principle. Le Chatelier's principle. Le Chatelier's principle. Now, we are going to look at that in the next video, Abi. Or we should let's just do it. Le Chatelier's principle. Le Chatelier. Le Chatelier's principle. Le Chatelier's principle. Le Chatelier's principle. So we are going to look at that in the next video. Thank you.